we talk about positive and normative statements. So it's the translation is on the blackboard. And let me give you another example. Something like, for the EMI course, the regulation asks me or asks the teachers should use English 100%, right? So is this statement a positive one or a normative one? The teacher of an EMI course should use English 100%. Normative, right? It is something you should. But does Roger use English 100% in the class? It is a statement of positive one, right? Because you may test or verify the statement is true or false. So Roger used English in the microeconomic course 100%. It's a statement that we may test or we may verify is true or false. But Roger should use English in the class. It's a normative one. So get it? Now we proceed to chapter 2. Okay, supply and demand. This is the definition of demand. The quantity of a good or service that consumers means you and me when we are buying something from the sellers. So we're consumers. So consumers are willing to and able to buy at various possible prices in a given time period. Ceteris paribus. So this is Greece, which means other things being equal. Ceteris paribus. Other things being equal. So in a given time period, in a given period of time, so within 1 day or within 3 weeks, or within a season or within a year, okay? So it's a very important condition for the demand because for every week, let's see, how many bowls of beef noodle are you willing to and able to consume in a week? The answer, of course, will be different from that if the time period is set like in a month or in a year, right? So the answer varies when you set different time period, and your answer will be different. And other things being equal, what does other things means? Other things include the prices of the complements or the substitutes, or your taste, or your budget, your income, your earnings. And at various possible prices, so at variable possible prices, consumers willing to buy, which means you have the willingness to buy. But most of us are willing to have a yacht, or have a house, or have a luxury car. So we are willing to, but we may not be able to, right? So the next condition is we must be able to. Not only we are willing to, but also we are able to buy the quantity of a good or services. So given various possible prices. If the price is high, then the quantity can be low. If we lower the price, we may increase the quantity we are willing to and able to buy, right? So it depends on variable prices, and there corresponds different quantities. Alright, so you see there are so many conditions for the definition of demand. So not only just the price and quantity relationship, but also these things. In a given time period, other things being equal, so we need to control other variables and various possible prices. We are consumers, willing, able to, and about the quantity. So the relationship between prices and quantities. Also, we need to consider other conditions. That is a complete definition of demand. And the demand function. So we use a lot of mathematics in the course. The demand function is a mathematical term. Describes a relationship, is a mathematical relationship between quantity demanded and the price and other factors that influence purchases. So, like this. Let me give you some examples here. Alright, if you need Wi-Fi, it's MGD, and the password is 0342271551. So, if I put down an equation like this, y equals 2x plus 3. So, on the plane of y and x, we can draw it, right? And it should be, or it is, a straight line. It is a straight line passing through the point of if x equals 0, then y equals 3. So 0 and 3. This is one point. And if x equals, say, 1, then y equals 5. So this would be a straight line. Like this, right? And you see it is a straight line, and also you see it's a increasing relationship, right? Or a positive correlation between x and y. And also we may find a slope. You know the slope? In Chinese is the slope. So the slope would be 2, because the slope is defined by delta y over delta x. So 1 extra unit in x can increase y, or can raise y by 2. So the slope is actually 2. And we may call it a relationship, which means y is a function of x. Okay? But what about if I say y is a function of x and z? there are so many possible cases. Like y can be x squared minus z plus 5, or y equals log x base, say, 2 plus sine z. So there are many possible forms to which satisfy the general form. Y is a function of x and z. And let me give you a simple one, like y equals 2x plus z. Then we have totally 3 variables. And it's difficult to draw a picture or draw a diagram for 3 variables in a 2-variable or 2-dimensional graph. So for the 2-dimensional graph, we need to control z. So if z is set at 3, then this function is reduced to this one, right? And what about if z is set at 5? Then the original relationship would be reduced to y equals 2x plus 5. Is that true? Right. And then it becomes something like this, right? So the straight line shift upward by 2. Then we have y equals 2x plus 5 here. Okay, so y is actually a is a function of x and z. But if you want to draw or to express the relationship on a 2-dimensional diagram, then you need to set the value of z. Otherwise, you just know the relationship between y and x is a straight line with a slope of 2, and can be shifted on the plan. Okay? Now, the quantity demanded is a demand function of price of itself, of this good, and the price of its substitute, 替代品 substitute. So we use S to express substitutes. The price of substitutes and the price of complements, 互补品. Okay? And income, we use Y to stand for income. And so on. So P is per unit price of the good, P is per unit price of the substitute, and complement consumer's income. And sometimes, for convenience, we work with a linear demand function. So, for example, this is not linear. This is not linear. But sometimes, or mostly, we use linear relationship to describe the demand, such as this one. So Q equals 171 minus 20P plus 20PB. B is good B, and 3PC. Okay, so B and C just stands for something else. Plus 2Y. So we can analyze this relationship to derive some conclusions, such as the higher the price, the lower the quantity, right? So it's a reverse relationship or a negative relationship, so that the price, the quantity, we know basically is a negatively sloping straight line. Okay? So basically it's a negatively sloping because the coefficient of P is negative 20. So you see a negative sign here, you know it's a inverse relationship. The higher the price, the lower the quantity, right? Or the lower the price, the higher the quantity. And you see the price of good B, the coefficient corresponds to this variable is positive 20. So what kind of relationship between good B and the good we are talking about? The more expensive of B, of good B, can increase the quantity of this good. So what is the relationship between these two goods? So good B is a substitute or a complement. Think about beef and pork. So beef and pork are substitutes, right? If you eat both. So when the price of pork rises, if the price of pork rises, you will consume less pork and more beef, right? So you see the price of pork goes up, you will see the consumption quantity of beef goes up. So it's a positive relationship between good B and this good. So from here we may judge or we may conclude that good B must be a substitute of this good because it's a positive relationship. Okay? So on the diagram, if the price of B goes up, then the demand of this good should be shift outward, right? Rather than shift inward, because it's positive. So you will see a parallel shift here. If PB goes up, so at the same price, at the same level of the price, you will see the quantity prime. The quantity increases due to the increase of PB. Okay, so the demand curve shift outward. And what about C? Good C is also a substitute, right? Another substitute. But if this is a negative sign here, if it is negative 3, minus 3, then what would be good C? Must be a complement of the good we are talking about, right? Understand? Then what about Y? Y is the consumer's income. So it's a positive sign here. So which means the more money you got, the more quantity you consume. So this kind of good is a normal good. It's a normal good. If the more income you got, but the less quantity you consume, then we will call that kind of good as inferior good. So this is normal means normal good, inferior good. So it is not necessarily that the increase in your income raises your quantity consumed. It depends what kind of good you're talking about. If the good is a normal good, then the relationship between the quantity demanded and your income should be positive. Otherwise, it is a negative one. So, can you figure out or can you think of something as an example that can be a normal good? For example, Haagen-Dazs ice cream. Do you like Haagen-Dazs? You enjoy Haagen-Dazs? So, if your parents give you more pocket money, you may consume more Haagen-Dazs ice cream within a period of time, right? And what kind of examples can you think of, like inferior good? Yeah, if you are not very rich, actually you are poor, then you may have your breakfast, lunch, dinner with instant noodles. Okay, 泡面, right? 方便面. So, but if you earn more money, if your income get larger or higher, then you may have beef noodle to replace instant noodles or 卤肉饭 or steaks. Okay, so another example can be, say, something like bicycle or motorcycle. So when you are not rich, you may have a bike or motorcycle. But if you get, after your graduation and after a few years, your work, then when your salary gets to above a certain level, and you may try to buy a car, an automobile, rather than a motorcycle. But some kind of motorcycle is expensive, but it's another product, not the normal one we are talking about. Okay, so got it? The definition of normal good and inferior good. So graphically, if we want to depict the relationship between QD and P, quantity demanded and price, we need to hold the other factors constant. That is what I was talking about, hold Z as 3 or hold Z as 5, so that we may depict the relationship on a diagram graphically. Okay? So, let's assume that PB, PC, and Y as these values. PB equals 4, PC equals 10 over 3, Y equals 12.5. Then the relationship we just described, the function we just described, can be reduced to 286 minus 20p, 20 price. And we may draw it on the diagram. And the slope, what is the slope? Q equals, let me put it down here. Q equals 286 minus 20p. So what is the slope here? Is it negative 20 or not? When you see the specific relationship between P and Q demanded, quantity demanded, what is the relation, or what is the slope for the demand curve? When we are in high school, we have already learned this. Something like this, right? So y is the variable on the axis, on the vertical axis, and x on the horizontal. So we keep y, the coefficient of y, as 1, and the coefficient, and then the coefficient in front of x is the slope. Right? So in this case, P is the vertical axis. P is on the vertical axis. So we should rearrange the relationship as 286 minus Q divided by 20. Or negative 20 1/20th Q plus 14.3. So this is the slope. This is not the slope because Q is the horizontal axis variable and P is on the vertical. So we need to keep the vertical with a coefficient of 1, and on the other side of the equal sign, the coefficient in front of the horizontal variable is actually the slope. So we rearrange this equation to find the slope. Okay? So the slope, as defined as delta P divided by delta Q, equals negative 1/20, or 1/20th. And negative 20 is actually delta Q over delta P. This is actually not the definition, not satisfy the definition of slope. This is the definition of slope. This is not. Okay? So what if PB increases to 4.6 from 4 to 4.6? Then the equation will change from this one to this one. So the graph, the demand curve will shift outward by how many? From 286 to 298. But from 286 to 298, so increased by 12, right? But this, the number 12, occurs to Q. So 12. This is the extent of the shift. Okay? So PB increases from 4 to 4.6. The increase is 0.6, and delta Q is 12. Okay. Supply, also linear supply curve, you can have this kind of relationship. So QS, the quantity of pork